People hear syscall and think low-level Linux trivia. It is not. A syscall is the exact seam where your code stops and the kernel takes over. Your process lives in ring 3. The kernel lives in ring 0. The CPU itself blocks normal programs from touching hardware or kernel memory directly. But programs still need privileged operations, opening files, sending packets, creating processes. The syscall instruction is the one legal gate across that boundary. This is not an arbitrary jump into kernel code. The process cannot pick where it lands. The kernel registers a specific entry point, and the CPU enforces it. Every Linux tool goes through this path. Curl, PS, IP tables, SS, IP, strace, they are all normal ring 3 processes asking the kernel to do work on their behalf. A C call, like write, looks harmless, but underneath it loads registers and fires the syscall CPU instruction. The kernel reads those registers as arguments. The kernel keeps a syscall table. Each syscall number maps to a kernel function. The number in racks decides what handler runs. When Python creates a socket, it eventually becomes syscall 41. The kernel allocates a socket structure in kernel memory and returns a file descriptor back to the process. Strace is one of the clearest ways to see this boundary. It intercepts and prints every syscall a process makes in real time. You can filter strace down to only network activity, file access, or process creation. That makes it an X-ray for debugging and incident response. Even starting a process is syscalls all the way down. Bash forks itself, then execve replaces the child memory with a new program image. Containers use this layer directly for security. Seccomp filters syscalls. If a blocked syscall is attempted, the kernel kills or denies the process. Ptrace is another syscall boundary tool. It is what powers strace and debuggers, but it also allows one process to inspect or control another process. The final mental model is simple. Tools are wrappers. Syscalls are the real work. Everything on Linux eventually bottoms out at this boundary between user space and the kernel.